Let's understand the concept of logical connectivities. Now here there are two kind of statement that you can see. Either that statement is simple statement or that statement is a complex statement. Now we are using connectives in order to take the simple statement into complex statement. So the first connective that we are using, that is OR. The second statement that we are having, that is AND. Third one can be written as NOT. Fourth one can be written as IF and then. And the last one, that is if and only if. Now if you can see here, OR statement can turn out to be, we will take two statements and then we can define it as OR. So suppose if I'm writing Ram will go to find a place or he will not find a place. So there are two statements that we are having. First one is Ram will go to find his place and or Ram will not go to find his place. There are two statements that we are having. That's why we will say that OR can turn out to be binary. Now similarly we will say AND is also binary, and if I'm talking about NOT, this one can't be termed as a binary, because if I'm saying you will go to school and the second statement that I'm saying you will not go to school, so every statement here is a single statement that we can see, because first statement is not dependent upon the second statement. So you will say this one is not binary, this one is only single statement. Fourth one, you will say this one is binary, and at last you will say if and only if is also binary. Now what is the symbol that we are using in order to represent this one? If I'm saying OR, it will be represented by this. If I'm saying AND, it will be represented by this. If I'm saying NOT, so this one is represented by this symbol, and if then will be represented by this, and if and only if will be represented by this. Now there are other name that we are having for OR. For OR we are having the name as disjunction, and for AND we are having the name as conjunction. For NOT we are having the name as negation, and if then if I'm using, that can turn out to be implies, and if and only if can turn out to be double implies.